Hi, I'm Cheryl Leach. In this problem, we're asked to identify both the period and the amplitude of the given sine curve. Well, let's talk about what a period is first of all. Trig functions are what we call periodic. That means if you look at one section of the graph, which we call a cycle, and you repeat that section over and over forever in both directions, you can create the entire function. So, what is a period? Well, the period is the horizontal distance required to get one complete cycle in. So let's go ahead and look at how to find the period of this particular function. We're going to look at it from both a graphical and an analytical point of view. So first, the graphical point of view. Let's go ahead and sketch one cycle. It really doesn't matter where I start, but I know that I have to get a complete cycle in, which means that once I finish my cycle, the graph should just be a repeat of that piece. And if you look, if I go to my maximum, my intercept, my minimum, and then my intercept, I can take that section or that cycle and just copy it over and over in both directions to create my sine curve. All right. I have an idea of what my cycle looks like, but remember, the period is the horizontal distance required to get that cycle in. So what I'm looking for is the distance from endpoint to endpoint of my cycle. Now, according to my graph, it looks as if this unit from 0 to my first hash mark is pi over 2. To get a complete cycle in, I need to move another pi over 2 units. Which means that graphically speaking, my period is going to be pi. All right, well, let's look at this from an analytical point of view, because sometimes it's a little tricky to read a graph. So what part of my equation tells me the period? Well, the period is going to be determined by whether I stretch or shrink that graph. And that's determined by this coefficient, the coefficient that you multiply by x. So this is what's going to alter the period from a standard sine curve. Well, I know that in a standard sine curve, the period is 2 pi. So I'm going to take 2 pi and I'm going to divide it by, we often call that the b term in my general equation of a sine curve. So I'm going to divide that by whatever the b term is. So in this case, b is 2. So I have 2 pi divided by 2, and I've calculated that the period is indeed pi, which is exactly what I saw looking at the graph. Okay, now let's talk about amplitude. What's amplitude? Well, you can think of amplitude as measuring the height of the graph, but it's really a little more than that. What you're going to do is you're going to find the difference between the maximum point and the minimum point and divide it by 2. So let's take a look at my picture. Again, we're going to do this graphically and analytically. So graphically, I see that my highest value is at 3. My lowest value is at -3. So if I look at that vertical distance, that's going to give me a total of 6. But for the amplitude, I only want half of that. So 6 divided by 2 is 3. So my amplitude is 3. Now again, what if I don't have the graph? Or am I really sure this is going to 3, or is it going to 3.02? All right, so it's a good idea to have an analytical way of looking at it as well. So when I look at the equation, the piece that determines what the amplitude is going to be this constant that comes out in front. We call that the a term. And again, if you think about it, a constant multiple of a function, that's what's going to stretch it or shrink it vertically. So to calculate the amplitude, what we want to do is take the absolute value of this a term. And in this case, the absolute value of 3 is 3. And so we indeed came up with the amplitude. That absolute value is important because every once in a while you'll run across a function that has a negative value in front of it. If that happens, the amplitude is still the positive version. The negative sign does something completely different. It deals with a reflection. But we don't have to worry about that in this particular problem. I hope that was helpful. Thanks.